Good day, everyone. I will help you to learn the majestic and interesting world of science. Before we begin, let me give you a short fact. Oh, it's so hot! Class, did you know that in 2.3 billion years, it is possible to be too hot for life to be exist in Earth? Our planet may become a vast desert similar to Mars as predicted by many scientists. That's why we have to conserve resources as it may help save the planet Earth. Examples are waste segregation. So by doing this, you lose nothing and you benefit from it. Well, that's the short science fact with Ma'am Annalisa Benito. For today's lesson, here are our learning goals. Discuss the concept of quantum numbers. Determine how quantum numbers describes the energy and position of the electrons. Today is another chance to learn and discover the wonders of science. Before we begin, make sure you have your pen, paper, and self-learning modules. Hello, let's begin. For today's video lecture, we are going to discuss the quantum numbers. It determines the location and arrangement of electrons in an atom. Further, it also describes the different atomic orbitals. Class, the quantum numbers will help you to know if what is the location, the distribution, and how is the arrangement, and in what orbitals do we found the electrons. But in this, we mention the word orbitals. If we look back, orbitals is the origin of probability where an electron can be found. In our previous lesson about the writing of electron configuration, we discussed that we have 4 types of orbitals. These are the SPDF orbitals with different shapes. Remember that these shapes does not literally refer to the electrons of an atom. These refer to the regions where electrons can be placed or found. One of these have the ability to hold pair of electrons. Let us always remember, as the number of electrons increases in an atom, the orbital numbers will also increases to accommodate the number of electrons present in the situation. Now, let us know the characteristic of different quantum numbers. Let's begin with the principal quantum number. It refers to the energy level of an electron. This is denoted with symbol small letter n. Has a value of any positive integer. We saw it already on the Bohr model wherein its orbitals has respective energy level. This means that in the principal quantum number using the Bohr model of an atom, if the value of n increases, the further it becomes from the nucleus of an atom. The second quantum number is angular momentum. This represented by the small letter L. This refers to the shape of the orbit. The value of this quantum number can be determined using the formula of n minus 1, wherein n represents the principal quantum number. Again, n represents the principal quantum number. Angular momentum or azimuthal. For example, if one electron has n value of 3, this will have an 1 value equals to 1, equals to 0, 1 up to 2, which is the result of our formula. Angular momentum, but when it comes on the highest energy level, electron configuration, or what we call the distribution of electrons. If we write the electron configuration of an atom, we are going to base it on the highest energy level resulted from the electron configuration. So how it happened? Let us base this in the L value of the orbitals. If the S orbital is in the highest energy level, the value of L is equal to 0, wherein the shape of this is spherical shape. If the P orbital is in the highest energy level, the value of L is equal to 1, wherein the shape of this is dumbbell shape, but it extends into 2 to 3 axes. If the orbital is in the highest energy level, the value of L is equals to 2. Okay, wherein the shape of this is 4-leaf clover. The shape of this is complicated, unlike the S and P orbitals. So let us remember, in the energy level of this, mayroon tayong tig 5 na 4-leaf clover. If the F orbital is in the highest energy level, the value of L is 3, wherein the shape of this is very complex and not easily to describe dahil ito ay may tag 7 F orbital sa isang energy level. The third quantum number is the magnetic quantum number, or M sub L. Describes the spatial orientation or a specific orbital of an electron. Its value depends on the angular momentum value, where it can be from the range of a negative integer 0 to a positive integer. Class, like what we said, its orbital has value of angular momentum number. For example, let's find the M sub L of P orbital because it has a value of 1. The value of M sub L of this begins at negative 1, 0, and 1. This will help to know if how many orbitals of a type of energy level at this best describe the particular set of quantum number. How about if you want to get M sub L value of S orbital, just like what we said, the L value of S is 0. So, the M sub L of this is also 0. That means it has only one orbital. The D orbital has an L value of 2. So, it has M sub L value of negative 2, negative 1, 0, 1, and 2. This will have 5 orbitals. M sub L will be our guide in placing the electrons our electron orbital diagram. The f orbital has an L value of 3. The m sub L value are negative 3, negative 2, negative 1, 0, 1, 2, and 3, as it has 7 energy levels. Remember, in writing magnetic quantum number, the value given to represent the m sub L will be valid only if it is covered from the negative to positive integer range of L value, or what we call the angular momentum value. The last quantum number is the spin quantum number, or the m sub s. It specifies the way the electron spin or rotates either clockwise or line ray up, or counterclockwise line ray down. So on its axis as it moves within the orbital. Okay. So its value can be positive 1/2 or negative 1/2. And no other values are acceptable. How do we know the set of quantum numbers? Let us try to determine the set of quantum numbers of given atom. Our example here is the nitrogen atom. Okay, we are going to follow a step-by-step procedure for us to easily understand it. First, let us know the atomic number of the element in the situation using the periodic table. In using the periodic table, we will see that the atomic number of nitrogen is 7. After getting the atomic number of the given element, next, write the electron configuration of the element. In writing the electron configuration, we may use electron configuration mnemonics as guide in writing and putting in distribution of electrons in its sublevels and orbitals of given element. Step 2. Write the electron configuration of the given element. Because nitrogen has atomic number of 7, the electron configuration of this is 1s2, 2s2, and 2p3. Just like what we said in our past lesson, the sum of the superscript must be equal to the number of atomic number of nitrogen. Step 3. Identify the highest energy level from the electron configuration. How to know the highest energy level? The highest energy level is found at the end of the electron configuration. In our given, the highest energy level is 2p3. Step 4. Write the electron orbital diagram of the given element. We will use electron orbital diagram as basis in writing of each electrons. In Hand's rule, we will put one electron in each orbitals represented by line ray facing upward before we put the pair of these, which is the line ray facing downward. Step 4. Write the electron orbital diagram of the given element. So we have here for nitrogen 1s2, Okay, it has a pair of line ray facing upward and then line ray facing downward, 2s2, one line ray facing upward and then one line ray facing downward. And for the highest energy level, so we have the 2p3, so we have 3 line ray facing upward. Now, let's write the set of quantum numbers of a given atom using the highest energy level of nitrogen, which is the Tp3. Step 5. Write the set of quantum numbers using the highest energy level. The principal quantum or n value of this is 2. Remember that the principal quantum number is the number found before the letter that represents the orbital. The angular momentum number or L value is 1. Why this is 1? As we look back, the orbitals has respective L value, wherein S orbital is 0, P orbital is 1, D orbital is 2, and F orbital is 3. If we use the formula n minus 1, because our n is equal to 2, let's subtract this to 1. So our L value is 1. While the magnetic quantum number or M sub L of this is any of the negative 1, 0, and 1. But how to determine the exact value of the spin quantum number or the M sub S? Class, balikan natin ang e-orbital diagram of nitrogen. We will notice that the diagram is filled with line ray facing upward. Tandaan natin na upang masabi natin na ang M sub S ay magiging positive, kailangan na tatapos ang distribution of electrons sa isang line ray facing upward. At upang magkaroon naman ng negative 1/2 na M sub S, kailangan matapos ang distribution sa line facing downward. Kung kaya, ang value ng M sub S ng ating nitrogen atom ay positive 1/2. Dahil mapapansin natin na sa highest energy level, natapos ito sa line ray facing upward. Now, let's read the complete set of nitrogen atom. Okay? The principal quantum number or the n value is 2. The angular momentum or the L value is equal to 1. And then the magnetic quantum number or the M sub L is equal to negative 1, 0, and 1. And last, the spin quantum number is equal to positive 1/2. Now, let us summarize our video lesson. Quantum numbers describes how electrons are arranged in an atom. Class, so we have 4 quantum numbers. 1. Principal quantum number. It refers to the energy level. Next, we have the angular momentum number. Refers to type or shape of orbitals. 3. Magnetic quantum number or the M sub L refers to the specific orbital of the electron. And last, we have the spin quantum number or the M sub S. refers to the spin or rotation of the electron. In each set of quantum numbers, you are going to identify the invalid part. Okay, class, you need to justify what makes it invalid. Our set of quantum numbers, so we have n is equal to 1, L is equal to 1, M sub L is equal to 0, and M sub S is equals to positive 1/2. Using the formula n minus 1, we can find the value of 1. L is equal to n minus 1 or 1 minus 1, wherein our L value is equal to 0. So class, dito natin makikita na ang invalid entry ay ang value ng L. Dahil upang makita natin ang value nito, gagamitin natin ang formula ng n minus 1 upang malaman natin ang eksaktong value ng ating L gamit ang formula na n minus 1. So, isa-substitute natin ang value ng principal quantum number sa set. So, magiging 1 minus 1 ang formula. At pag in-apply natin ang operation, magkakaroon ito ng value na 0 na nangangahulugan na hindi tama ang set na ito. Okay? Using the formula n minus 1, we can find the value of 1. In each set of quantum numbers, identify the invalid part. You need to justify what makes it invalid. In this set, n is equal to 2, L is equal to 1, M sub L is equal to 1, and M sub S is equal to positive 3/4. Okay, M sub S has two possible values, and it can be positive 1/2 or negative 1/2. In this set, the invalid entry is M sub S. Just like what we said, spin quantum number has only two values only, and these are the positive 1/2 and the negative 1/2. In each set of quantum numbers, identify the invalid part, so you need to justify what makes it invalid. In our third set, n is equal to 0, L is equal to 1, M sub L is equal to negative 1, and M sub S is equal to negative 1/2. The value of n should be any positive integer. So in this set, okay, the invalid part is the value of n, because always remember that the value of n should be any positive integer. Class, thanks for listening and save